Hey guys, this question would like to know, what do SN1 and E1 reactions have in common? All right, now if you look at this, we kind of have to investigate our answer choices to even know what we're dealing with. But, let's go over SN1 and E1 reactions just a little bit. SN stands for nucleophilic substitution, right? And remember, SN1 is also known as solvolysis, okay? Volysis. It's basically that reaction where the leaving group leaves, forms the carbocation, and then the solvent molecule, usually something like water or methanol or ethanol, will attack the carbocation again. E1 starts the same way as the SN1. It also forms that carbocation, but instead of the solvent then attacking the acting as a nucleophile and directly attacking the carbocation, thereby making the replacement, the substitution product, the solvent would then instead grab a beta hydrogen. So in other words, it kind of looks like if this is your carbocation, then the solvent molecule would rather grab the proton nearby, kind of like a base, and give you an alkene as your product. That's what we get by eliminations. The E stands for elimination of a first order. The first order just means that the rate of the reaction only depends on the concentration of the substrate. And so the nucleophile or the base or what concentration does not affect the kinetics of the reaction. Okay, it also means it's unimolecular. And what else? We also remember that elimination reactions are favored in heat. And substitution, typically, if you heat a reaction up, you'll typically favor the elimination. Okay, so let's go through our answer choices here. Let's see. It says for A, they are both second order reactions. Okay, well, we kind of just ruled that out, right? We just said they're first order. That's what the 1 stands for. So A is incorrect. B says they work best on primary alkyl halides. That's an interesting one. Well, we both know that for this mechanism, for both reactions, the first thing that happens is the leaving group leaves, right? So say you have the leaving group there, bromine will just leave and form a carbocation. Now, in the case of the elimination, a proton will be abstracted to form the alkene, whereas in the case of SN1, the nucleophile will simply attack that and you'll get a substitution product, like so. But in both cases, you form a carbocation. And remember, tertiary carbocations are much more stable than secondaries, which are much more stable than primaries. And in fact, primary carbocations are very unstable. So you do not want to form a primary carbocation. So that's why primary alkyl halides do not work best. So B is out. C says they both form alkenes as the final product. That's untrue. With the substitution, you just get a substitution product, whereas with the E1, you get the alkene. So C is out. D says they both proceed through a carbocation reactive intermediate. Ah, fantastic. That is true. We have just kind of went over the mechanisms, and we know that that is definitely true. They both form a carbocation intermediate. All right. And then finally, E says they are both one-step considered reactions. That is untrue. SN2 and E2 are one-step considered reactions, but SN1 and E1 are two-step reactions. It's kind of counterintuitive. You think of SN1 and E1, you have to remember those are two-step reactions. Okay, so remember the numbers have nothing to do with the amount of steps, because it's sort of the opposite way. SN2, E2 have a one-step mechanism, whereas SN1 and E1 have two steps in the mechanism. Okay, so remember it's flipped around in that case. All right, thanks guys. I hope this was helpful. The answer is D. If you have any questions, shoot me an email. I'd be happy to explain things in more detail. Have a nice day.